myself. My name is Roland Vertus. I work in the marketing team of Isovalent, and I'll be your host today for this webinar. And with me are David and Andre from Tier2Every. They are both SREs at Tier2Every Industries. They will talk to us about basically more than just a CNI, how Cilium helped them with their cloud native stack, with their cloud native challenges. And with this, before we start, there's one thing I'd like to highlight. If you want to ask questions, feel free to do so. Two ways basically to this. Either you put them into the chat, or there's an actual Q&A box you can start. In the Q&A box, then we will answer the questions already and put them live once they are answered. We will run through the webinar and we'll also address the questions at the end of the webinar in case they weren't answered in between, or in case you still you have questions for Andre and David. So with this, having said that, I'll hand over to David.
Yes, thank you. Yeah, my name is David. I work as a senior site reliability engineer at Tier2Every. And I have with me my colleague here, Endre. All right, Endre, take it along.
Yeah, hello, I'm Endre from the same company. I work in the part that is called, or rather we work in the part that is called Tier2Every Industry, and industry is a subpart of the Tier2Every family of companies. We're like a separate entity within the group. We focus mostly on innovative or segment-specific solution, industry-specific solutions, I would say, that is then pertain to education, energy, public 360, that is case management for municipalities and government. And then we have data platforms, which I am a part of. So we are a decently sized company with a lot of revenue that deal in more specialized or industry specific solutions, kind of. Next slide, please. My department deals then mostly with what you would call even more like we're a part then within the industries or industries. How would you say this? The industry part of the company. And our department is almost like a separate thing within the company again. And we deliver services that are towards mostly private and public sector and energy clients, banking, finance companies. So a lot of different kinds of businesses. But it's focused a lot on B2C and B2B solutions. So we have solutions within billing and invoice as a separate entity. They handle stuff like e-invoicing solutions. So like when somebody ships out an invoice and they want to get it to print or like a PDF or generated, that goes via us. In both, a lot of it goes in via us in Sweden and in Norway. And we have a product called, for example, Kivra in Sweden. If you're Swedish, I saw a Swedish person here. That is hosted by us. And I believe Swish as well. We have something in there as well. We have data services which is mostly Norwegian focused, but we deliver then the National Debt Register, or Gjeldsregisteret, as it's called in Norwegian. So that is basically a large registry of all the debts in Norway as an API that it comes with the data from all the banks. And then you can go in and you can see like how much debt you have as a citizen, or the banks can use the data and buy access to it. We have AML solutions, registries like anti-money laundering registries, meaning we used to have a lot of APIs for stuff like the National People Registry and boat registries and car registries, and a lot of data you could buy from this department. And they use this to also make services for data washing and extract, load, and transform kind of services for the customers, where typically the customer would have a demand, and then we can make also custom solutions for them. Industry messaging, if you're into B2B stuff and you have heard about Peppol access points, for example, that is hosted by us in a lot of it in Norway and in Scandinavia. We do a lot of business-to-business messaging and brokering integrations. And the umbrella product for that in one part of the department is called Business Information Exchange. As an example for this, if our solution goes down, you will not be getting your postal package before Christmas or before Black Friday. And I believe there is tons of other services without me knowing all the stuff that the business powers with this.
And we also have the digital solutions, which connects all banks to any type of registry, both the National Population Registry. So like in Norway, you don't do any physical mortgage documents and so on. Everything is digital and it runs through our systems.
Can we go to the next slide, please?
Yeah.
So when we started this journey, it was 4 years back-ish, 4 or 5. I came in as a consultant, and we started to talk about vision for the department. It started off by choosing or thinking of what they would like to have from an atypical platform. They wanted to have networking, so you need to be able to receive traffic from coming in from the customers into the various solutions and portals, APIs, and maybe even TCP services we have, because we do have some non-HTTP or non-RPC kind of stuff as well going. We wanted to be able to do workload to workload traffic. More specifically, being able to open for traffic between things without having even multi-cluster stuff, without having to do a lot of ingresses, because that's a fun maintenance burden to have maybe tens or hundreds of ingresses going when it's only an internal app. We needed to think about security policies, or if you could define firewall rules of sorts for it, and also maybe encryption. It would be nice to have monitoring, of course, added security, the more security the platform can have, the better. Standardized APIs. So something like the Kubernetes resource model is always nice. If you can make it in YAML and use GitOps, it's awesome. A ecosystem and a community around it, and scalability and self-healing. So if you go to the next slide, please. So talking a little bit of our footprint. We are divided in currently not into hosting, call it big clusters, but we have more smaller clusters due to some questions about having to show where the money is spent, especially in cloud at the moment. So that ended up with having smaller clusters and not big ones. And also because we needed to put some of the clusters closer to where the old legacy is. So stuff like databases, file stores, already existing systems and integration with networking and so on is also a big thing for us, because we do have a large footprint and we don't have the manpower to do a big lift and shift. So we have about probably the biggest currently, which is the data services users or group, which is 154 app instances over 4 clusters on 16 nodes and 22 namespaces. And then we have the smaller billing and invoice, which is 20, but expanding at the moment. They're expanding use into more, you could call it hybrid cloud usage at the moment, on-prem, or like a, how do you call it? It's almost like a cloud-ish system. But they're going to be moving more into Kubernetes and moving away from other things, and they have already containerized a lot of stuff. We have industry messaging, which is then hosting this PEPL service, for example, and the postal service system. They have moved also about 93 apps in Norway into cloud-based clusters. And they're starting to use in Finland and in other countries as well, more like a on-prem private cloud approach. So quite a decent, I'd say, footprint. A lot of value going on the data services and industry messaging revenue-wise on this. Example is data services is powering roughly, I think, 12 to 14 million euros. Industry messaging systems is powering a lot of stuff in Azure with Cilium at the moment. So you can't, for example, you can't do voting on the national election day if it goes down, because the ballots will be sent via us in Azure. And that is just the ones that I know and keep track of. They're constantly expanding. Next slide.
Yeah. So in the early phase, we have, as Andreas said, we have multiple clusters, different cloud solutions. We have some in Azure. We have some at a third-party hosting provider. And we also recently have started deploying multiple clusters in a VCD VMware environment that we are in-house hosted in Tietoevry. But a lot of the problems that we ended up getting into in the beginning of starting to run Kubernetes and starting to get a lot of applications up, and a lot of our applications also talk to each other. It's not just putting up an app, making it available on the internet. Is also that we started getting a lot of tool sprawling. We started with Calico for the network interface. We started, well, of course, we use Ingress, we use traffic. We also started experimenting with different service meshes like Solo and Istio, and that was okay. But the more tools that is not from the same company makes things more complicated, and patching and everything. Also, for enterprise-grade solutions, like a lot of enterprise tools gets very expensive, and then if you have to pay a lot of money just for one simple tool, it's also a budget constraint. So we saw the need to start to consolidate things. That's kind of when we noticed Cilium and saw their roadmap, what they currently offered, of course, and also their roadmap, and started using that, testing it out, started moving over our clusters to running Cilium instead of Calico. We also saw quickly we could replace Istio, and recently also replace traffic. And also another thing, one of the reasons why we started testing out Cilium was because Cilium came with Hubble inbuilt, and that was really a game changer for us, because then we could actually get full network observability. And DNS-based network policies are also very handy to have. And that.
Yep. So we ended up choosing or using, now we use a mix of different Kubernetes distributions, where we typically use something like AKS, RKE 1 or 2, or the VMware VCD based flavor on VCD to bring up a cluster in a given network, typically that is either integrated or not integrated. with the rest. It's a bit of a fractured environment at the moment, so there's some work that has been done to try to integrate the networks. We have traffic for ingress. As David mentioned, that is maybe going to be replaced. We use Cilium for networking to do the networking on the clusters themselves, and also to do multi-cluster networking. We have the standard stuff with Flux and Argo for like the config management. For infrastructure config management, it's a combo of Terraform and Cluster API. And then for the source code, it's GitHub and CI actions. And we're like then spread across Azure, what they call Sovereign Cloud, which is our product name for the vCloud director, basically, or VCD, if you know the VMware stack. I think they also called it for Tanzu, partially. And then we also have the RKE that was mentioned across like traditional VMs on-prem. So it's quite a diverse footprint, if you will. And then we also use tooling or a tool called Q, which is like QLang, to do some templating of the GitOps code, or the stuff that goes into the GitOps. So next slide, please.
Yeah. So one of the things that we got a very difficult project after started using Cilium, and that was to save a legacy a 15-year-old legacy application that was quite big. It was a classic monolithic application installed on a few servers and been running ever since. It was a big part of the revenue stream for data services. It consisted of a lot of functions that did a lot of API integrations between multiple public and private sectors, both banks, different public registries, and also other type of companies that needs to be able to, for example, look up a person by its social security number, or check if a person owns a specific property, or it was used for a lot. And the problem was that the hosting provider couldn't basically move the application to a newer version of a long-term support for Red Hat. So they figured out that since we created it and we just paid them to host it for us, we needed to basically either fix the app or do something, because they could not keep support for the application for more than 1 year. So we got to work, basically, to say the least. Some of these API calls could, for example, have 5 hops inside the application itself, between the different API endpoints, or towards some registry, or towards some customer or partner. So it was quite a big application. So in the start, we started, of course, moving the old application, the source code for the application, to, well, at that time it was fairly new GitHub solution that's hosted internally. I started process, but it was decided to containerize the application and running on Kubernetes instead of installed on some static Linux server. So we started the process of splitting it up into, and
Did he just drop out?
Yeah, it looks like we lost David.
Oh.
Andrew, maybe you can
I'll
briefly
try to
reach out to him or take over.
I'll see if it doesn't answer within like 30 seconds. Yeah, I'll take over.
Sure. I think we have
try
30
at least
seconds
to do the storytelling.
Oh, there he is again. We can't hear you right now. Ah, there you are. Yes.
There. I'm sorry for that. I just suddenly lost a network connection. Give me a second. Am I still sharing my screen?
Not anymore.
Give me one moment.
Yeah, sure.
I am terribly sorry. My network just died.
This is.
There we go.
I think basically everyone online has had these situations already.
Yeah.
Cool.
All right. Are we back to where? Yeah, we're back to where I was. All right.
Thanks.
Okay. We also, like, since the application was stored in a very old version of Git, not GitHub, we also started implementing CI/CD practices using GitHub Actions. We also started, with those CI/CD practices, we also started with creating Docker images, both shared Docker images for the entire solution, and the individual applications, so that we could separate constraints and separate concerns for security, but also easier maintenance. And if we need to roll out something new, we could, do it in one place and then easily spread out the configuration. So phase 2, which was the hard part, is that since the application was very, very old, we only had one guy left in the company who actually even worked originally on the code, and he was now a manager. He was not a software developer anymore. So yeah, we had the fun of actually understanding a lot what the code actually does, getting that done and starting rolling out different things, we also implemented zero trust into what that comes automatically from the platform by default. We also had to do, of course, since we were running zero trust, we also had to do a lot of network policies inside Kubernetes platform, where we also used Hubble quite extensively to make sure that the applications could, get secrets, for example, from Vault, traffic that comes from the ingress goes, Argo CD could, manage the applications into the GitOps fashion. And, we can also pull images, for example, from Harbor. Whenever developers would deploy new versions of their apps, and we needed that to be deployed in Kubernetes immediately. And phase 3, while using Hubble and getting the applications containerized, divided up into its own functions, etc., we used Hubble quite a lot, because the code that was in basically the application code originally created had a lot of URLs written into it, hard coded. So, and a lot of the time the developers did not understand or where was the traffic actually go, right? Like if it needed to go to some registry, what is the URL? So this is basically where Hubble was a lifesaver, to be honest. So we gave Hubble access to the developers, and the SRE also helped at every single step for every single of those 23 apps to do the transition, while also, of course, teaching the developers how to use and work with Kubernetes, and also, shift over some of the responsibilities, at least for the more repetitive tasks, to the developers that would have to operate the application afterwards. Yeah, phase 4, as I said, assisted troubleshooting. We had implemented additional security features, moved the application, of course, to production, and also, pinpoint network traffic flow in production, because test had their own network endpoints they were going to, and production had their own. Each single environment had their own endpoints that needed to basically be logged, written down, and then, of course, open up, and also where applications would talk to each other, because some applications needed access to different registries, so they would talk to each other. So getting all that traffic to actually go and work, and that our customers would get the result they expected, was quite an extensive project. It was fun, but it was yeah, it was quite extensive. I think we were about 10 developers on this, and it was yeah. So yeah, using Cilium on the legacy app. So I think using Cilium, it saved us most likely a whole year. I don't even know if that project would be possible without Cilium, because the code was just so old. Barely a lot of developers really struggled to actually get to move it. Yeah, so using Hubble really accelerated the troubleshooting. So we could, yeah, we probably spent 3 weeks, 3 to 4 weeks for each app to get it tested in each environment, and test that all the functions and all API calls work, and they delivered a result that is expected. Because a lot of our customers, they have their own web solutions, like say a net bank solution or a mortgage digital solution, right? So it had to work automatically. It had to work flawlessly, or else the end user would get errors. So yeah, the benefit of using Cilium and Hubble is that it's really easy to implement zero trust. Because one thing is that you have the DNS-based network policies, while using any other CNI like Calico or Flannel, you don't have DNS-based network policies. So then, like for us with the legacy app, that probably had about 70 to 100 network policy openings, if not more. And a lot of those aren't, well, they are DNS-based, they're not over DNS. And and that really makes things easier, especially for in an operations fashion, because if a DNS is behind some sort of traffic management, having that API switch, now that IP switch, is yeah, would make a constant headache maintaining that application, instead of just opening up the DNS lookup address and then it's done. If that DNS in the backend changes IP, we're not affected. And also using the Cilium network policy editor from Cilium is also very, very nice, especially if you're really early in the morning. So you can basically load in your network policy, and you can basically sit in the editor on the web, and then just yeah, look into and make sure that your configuration is correct. And also sharing that with the developers is also really handy, because they're not that experienced with Kubernetes and even network policies even. So it also helps them, which in turn helps us as SRE. And one of the other cool things that with the enterprise version is that you can also see like if you implement certain configuration to your network policies, you could also see the latency between the applications, which is handy when you start troubleshooting if certain API calls are slow. Why are they slow? Where are they slow? Of course, the least. That's almost the most important part. And yeah, Hubble also makes it easy to simplify the connection. If your apps is grabbing, say, a authorization bearer token from Keycloak, or it's trying to grab some secrets or certificates from Vault, say through cluster mesh or a service mesh, it's really handy to be able to have both the Cilium network policy editor or Hubble to watch the traffic being dropped or going through live. It's, yeah. Endre, take it away.
Yeah, so we started to have a lot of, when we did this, we started to use stuff like Istio and a lot of ingresses, but I mean, the end goal would be to basically not have to use an ingress to say, oh, I want to have one app in one cluster, call out over into a different data center to a different cluster, and then have to put like an ingress in front of it. I would like more, hopefully, to use something like a service mesh, ideally. But what is nice about Cilium is then you can basically, hopefully, don't have to install a different service mesh like Istio or Linkerd with a new version, because we want to get like the mutual TLS in there, and we want to be able to link them seamlessly, and then also there's a nice benefit of getting like the MTLS information and even the binary information in the latest versions coming. And you can do the internal load balancing just via one tool. And then actually, as we mentioned earlier, you can get rid of one more, because now you can use the gateway API. And then suddenly you can pretty much get rid of like having to install a different ingress as well. So you can use Envoy with the Cilium that comes out of the box, which is really nice. So we are hoping we could start to transition over to just using Cilium and replacing the traffic basically that we run at the moment with this instead. So if you go, we haven't looked at like killing other services at the moment, or like tooling with Cilium, but there's probably some other use cases as well. So why bother with cluster service mesh? We have workloads running typically in different environments. So we have potentially different, we're in like a migration period. So we might be running workloads in different regions or different data centers, and even different cloud zones or regions. And then using this cluster mesh or service mesh actually would then allow you to do the load balancing across them, and then try to cover the encryption NFR as well, or the requirement. We haven't though yet gotten to a point where we're adopting gateway API or service mesh or the mutual TLS part. That looks pretty nice. We actually just upgraded some of our clusters to 113 Enterprise. So that might be something we can look into closely, I hope. Next slide, please. But cluster mesh may sound very, very fun many times on like on the sales pitch. And depending on how you use it, or set it up, they have support for this cert manager, which basically means you can use something like a shared CA that cert manager supports. And typically what you would do then, you would set up like one shared CA or PKI infrastructure between all your clusters. And the cluster would then, when you set up the thing you want to use, you have, say, the cluster mesh API server would go and grab a TLS termination or encryption certificate to encrypt its own, or like the certificates it's serving its own endpoint with. And then the client, which is then basically the Cilium agent, that will go grab that will get like a separate certificate from the same CA or like a client CA, and you would just give it like a reference to a cert manager managed secret, or even in the Helm chart, just say I want to use cert manager, and it will happen flawlessly with the issuer basically from cert manager, and you wouldn't have to care of anything, right? So it turns out that is not exactly the point at the moment, or like the dream isn't totally there at the moment. It's not that easy. So basically the workflow when you use the cert manager at the moment with a shared PKI or like a CA, it means you need to go in and you need to collect the certificates from the various clusters into a file. You need to take that file and apply it as a secret to all the clusters that is in the mesh. And then of course you can do this with the CLI, but then I don't know, haven't tested that before because we set this up before the CLI stuff was added. So what it would be really nice to see would be more like, oh, I can enable cert manager, I can integration, and I can give it a shared issue basically with some settings. And then when you do that, oh, you can reload the agents and the cluster mesh server once, and then it will come up. And it will renew, because the point of using this CA is like after a given time frame, your certs will start expiring, right? But if you don't update then the certificates and you don't restart this stuff for the Cilium components, well, then suddenly you're out of luck and you'll have a nice outage with all the traffic going between the clusters, because suddenly Cilium doesn't want to play ball, like cluster A doesn't want to talk to B and not B to A anymore on the cluster mesh because the certificates are expired. So if you forget that, it'll be biting you in the behinds, to say the least. And you'll get like people saying your stuff doesn't work. Of course, you could monitor this, and you can monitor like, oh, is the cluster mesh API server serving a right certificate, and is it using a right certificate in the Cilium agent? But there is no metrics in the Cilium agent, and there isn't. If you still think it would be up for a better user story to look into how it works in operations with this support. So next slide, please. So we do these secure defaults. So we do put like a namespace default policy into every namespace. That opens up to platform services, to inside Kubernetes services. It turns on DNS visibility by default. And we're using a queue tool to do a lot of templating of this. And this then gets put into the cluster's GitOps repository and then synchronized into the cluster. And then every app or the team basically has access to the repo as well, and they can go and edit a policy that is being set up per application to open all the other stuff basically that they would like to do. So stuff like application-specific endpoints to external APIs or services to open between their own services and so on. If you go to the next slide, please. So this is like a bit on that, and then for oh, that is actually the same. I forgot to change the slides. If you go back one again, we do manage then this queue template, or like the default one, in a central repo. And then we can basically like roll out, say we have like a new platform service or like a new component going into the cluster, and we want to make that available for everybody. We can do that in a template, and then we can push the contents of this template out to all the repositories, and then everybody gets it basically. So next slide. Platform services are typically like back office stuff, like common authentication services and Azure AD, for example, if we opened for, and a lot of other things. Inside of Kubernetes, it's the OpenTelemetry, Prometheus, for incoming traffic to the app on a default port. So we use 8080, for example, by default on all applications that are web-based. We open for like outgoing OpenTelemetry traffic or certain traffic. So like you can do Zipkin traces, Jaeger. If you use OTel, you can use OTLP. And then we open for the ingress proxy by default, and we open for some various other things as well. And we turn on DNS visibility settings by default also on the namespace level. If you go to the next slide. So we have the teams are often managing their, or have the possibility to manage their own settings of the app that they then apply to their own application label that matches, like their policy will match, for example, the pod label, so like app Kubernetes IO and then some name. And then they can manage their own openings between applications and also going to external services and even internal services as well. And this is then done with a code review at the moment with like the SRE team often, or like one DevOps engineer more in the team. And it's shared in the same repository on the cluster level, because that is what we have gone with so far. And then that is on the Cilium level being merged together with the default rule set, basically. Next slide. So we did have some thoughts of where do you want to go from here. So on the networking level, we want to do moving the same stuff that we talked about. So we want to move to the gateway API and all this. So basically we can get rid of having to upgrade traffic every time there's a new traffic version or ingress controller. We can just use Cilium. Maybe look into egress gateway on where we need to have like a stable egress IP or like fewer IPs going out for security. Service mesh we have mentioned already. If you go next, this you can do.
Yeah. So for the security, we could also implement and use Tetragon. We have discussed using Falco, but yeah, since we are an enterprise customer, at least testing out and running out Tetragon would be very useful, considering also Tetragon has most likely access also into the network layer more thoroughly. And then we could also send, for example, a security alert to Slack. And also the cool thing about Tetragon is also the deep inspection of application process. A tool like Falco cannot do that at the moment. So if you want to start doing application inspection or process inspection, you would still have to use a tool like strace, while with Tetragon that comes inbuilt. And then utilize some form of, for example, enforcement policies. Let's say if you want to limit which type of Docker registry you want developers to be able to use, but you only want them to use the internal one. If you want some sort of label policy that all applications should have a certain label, or maybe some security, like enforce the security settings. Let's say you don't want any containers to run in privilege mode. That could be very useful. And observability. So we would also like to implement Hubble Enterprise, like this central dedicated Hubble Enterprise, where we could like feed in all the network traffic from all the clusters into one single Hubble instance. Right now, we use the one Hubble instance per cluster. That is the default one. So that could also give us some more pluses, like more benefits by doing that. And yeah, one thing we've also been looking into is also enabling Hubble Timescape, so that you can actually go back in history to look at network traffic and not only live traffic, which is the default. Yeah, that was it. Thank you. Any questions?
Thanks. Yes. So let me briefly, before we come to the questions, let me briefly say thank you very much for the presentation. Thank you very much for the insights. And for those in the audience, if you want to try any of these topics described here, like golden signals or HTTP and TCP data, and also network policy, zero trust, and so on, we do have labs around those topics. If you want to basically get your hands dirty yourself, isovalent.com/labs. But to the questions. So number one, you mentioned Hubble. Were you using the CLI or the UI or both? Any preferences? Any recommendations?
Both, because maybe for people that don't know or don't have a background with stuff like TCP dump or stuff like this, Wireshark on looking at that, I mean, Hubble looks very simple and is very attractive just to open it in your UI. So we actually made like a macro or like a thing that you can run, and it opens the port forwarding and spawns like open the browser automatically. to a port. But then if you're looking for stuff like, okay, give me all the drop traffic, for example, on the whole cluster, Hubble doesn't look that useful in my mind.
Yeah, like for me also, I mostly use the GUI web interface version. Because mostly I'll be looking into given application. Like I haven't mentioned that before. Like I mostly work with data services applications. It's more than enough to fill a FTE. So yeah, using Hubble GUI is actually quite useful. The CLI can get very crowded, so it can be a little bit difficult to sometimes to actually like use it very effectively if you have to be quick and you're running low on time. So yeah.
Good. Then regarding the migration, the monolithic app you described, looking back, is there anything you would have done differently regarding Kubernetes and Cilium? Right, you laid out the 4 steps. Anything where you now looking back, you would think, hey, next time I'm going to migrate a huge legacy app into 23 containers. Anything where you would say, next time I'll go down this path, or I'll do this or that.
Yeah, I think next time, I'd most like I'd use I'd love to use the kube proxy replacement. That would be nice to actually have, since it also adds in a lot more performance on the network layer. And I think I would most likely also use some different types of images. Yeah, but it's a difficult, like those old applications are very difficult. They use also very, many times you'll find out they'll use a very big variety of libraries. So yeah, but for the Cilium part, definitely kube proxy replacement, without a doubt.
Makes sense. Cool. Then regarding Calico, did Cilium require more or less time maintaining and operating the setup compared to Calico? Any insights on this?
I think, I mean, we've been doing bring your own CNI kind of stuff on Azure even. Before the bring your own CNI stuff came along. Then we used, but that was a quite fun one because it came back and bit us in the behinds basically when Azure basically said like, oh, we're gonna screw over your setup. That was nice. Suddenly, like all our clusters with Cilium didn't work properly anymore because like the node taints just went away. But after we moved to the bring your own CNI stuff, I mean, we do a lot of GitOps and like templating. So like updating Cilium across like 5 test environments is pretty easy. Even on-prem as well, because if you have like GitOps and you do templating it out, and then it will just be there pretty much.
I think we reinstalled like the 20 clusters that we have in Azure, like first once to move to Cilium, and then it was again because of the bring your own CNI, and then it came with the official support, and then we had to do it again. So yeah, it's
No, we didn't do it again after the bring your own CNI, but there was there was an event when we basically had to move again after already having set up the Cilium CNI. So that was that was quite irritating to say the least, having to do like one more round.
That's at least a fun part when you have you have deployed everything Kubernetes with a template, so it makes it a lot easier.
Also, I like to highlight that these days, using Cilium on Azure, or technically on all the big clouds, is much easier because we basically are the default on a lot of them. Yeah. Cool. So, though you didn't mention Calico this time, right? You only refer to Cilium on Azure, but any experience in terms of comparing, or I know you mentioned the bring your own, Calico.
Yeah, but for me, like Calico is just like, for me at least, Calico is just a network interface. It doesn't really provide you anything else than a network layer and a network policy. Like you're not going to get anything out of using Calico except for basically a network, right? Cilium just brings a lot more to the table. you know, and especially now where you don't have to go out and grab traffic or, you know, run an Nginx ingress controller. You can basically just use Cilium out of the box as it is, and it'll work very, very well, and it'll scale as well. If you're into really big clusters with a lot of, you know, thousands of nodes, if that's your thing, it will do it.
Yeah, cool. And you mentioned Istio, and there was a question: are you missing any features in Istio that you can't use because you don't have Istio now? Is there like anything specific where you'd say this is something?
Yeah, there is a question or like a debate now within some of the legacy parts that are now looking into like, okay, can we get certain features off of the proxies, for example, to do stuff like authentication on the applications, for example, without having to deploy any other kind of like sidecar. And I do know that one of like the main things you could do with Istio, you could plug it in and you can say like, okay, I want to apply to any application that wants it, I'll give it like a OAuth protection, for example, by default. So that like, oh, you just configure it like a middleware, and then you suddenly just get like the Azure AD login, for example, for free, or get like the token protection for free and stuff like this. Because sometimes you do deploy maybe like a old portal app, for example, and then being able to use the service mesh, more advanced service mesh features, like not only the load balancing stuff or like retry stuff, but being able to apply custom filters and maybe extending it with stuff like WebAssembly and all this. Some cases can be nice, I think.
Cool. Fair assessment. Thanks. Good. These are the questions I had or were posted. Then, if there are no more questions in the chat, just looking.
I guess I can give you one Cilium usage for free that we did use it for. So during this data services thing, we were deploying a lot of applications, and they're old. They have a lot of shenanigans with them. And when you deploy old applications, having insights into the networking layer on other stuff than what is it communicating with if it's not working. It might be other stuff than, oh, it's just blocked. It might be your application is behaving badly due to old code, for example, or badly written code. So it turns out that DNS is always the problem, even in Kubernetes. If you factor in that Kubernetes does like DNS recursion by default, it does up to 5 requests per TCP connection you're doing, or UDP. And if you don't disable recursion and you don't have DNS, say not DNS, but Postgres connection pooling or connection pooling and client reuse, you can take the request count coming into the system. So we had about 2,000 incoming requests per minute. You can time that with a rough on average connection rate of 3.5 and time it up with like 5 DNS requests per minute in the cluster. And then time that up, and then you get like, it's a lot of DNS requests. And that will kill basically your core DNS. And then we used Cilium basically to try to pinpoint pretty often, like, oh, you've moved an old app, but it doesn't use, it's bombarding basically the DNS service, or bombarding the service because you're not using, like it points to you not using connection pooling, for example, or client reuse. So
that's cool.
That was fun.
It was doing
that was the classic. That was the classic. That it is DNS.
Yeah, it's always DNS.
It is actually 35,000 roughly DNS calls per minute.
Yeah, it was quite massive.
One system.
That was actually from that legacy app, if I'm not mistaken.
Yes.
My memory doesn't trick me. Yeah.
But we have had some of them after that as well. Just saying.
Cool. Yeah, thanks for the insight. Thanks for sharing it. And I mean, you mentioned the nodes the numbers previously roughly to me, but this is always like For me, it's unbelievable. Cool. We are basically at the top of the hour. Just questions came in again right now. For everyone who just posted questions or who still has questions, feel free to reach out to us via LinkedIn, Twitter, or something else via social. And we are happy to connect you or to forward the questions or try to answer them for ourselves. To David, Andre, thank you very much for participating. Thank you very much for the presentation, for all the insights, for all the details, and for this, well, real world insights. That's really valuable and it's great. And for all the participants and attendees, thank you very much for being here and for joining us. And wherever you are, I wish you a wonderful afternoon, morning, evening, and rest of your day.